Hello again. We are Jayita here with a presentation of DSPy, the declarative programming in the era of AI. Please.
Am I audible?
It's okay.
Oh, that's what I say every day in Teams. All right. Good evening, everyone. And yeah, I guess you're already pumped up with all the Plone conference going on, and all day you're attending PyCon talks. So I'll try to entertain you a bit with a more lighter topic, maybe. And yeah, let's see. I'm going to be talking about DSPy, and we'll find out through the session what it is about. So a little about me. I go by the name of Jayita. If you want, you can call me by my initials, JB. I don't mind that. I am a data scientist, and my job is to just do wipe debugging inside the Jupyter notebooks, because already AI can do the job. I have to be the debugger. So I love speaking at events, and this is my first time traveling to Finland, and I'm excited to bring value here. So thank you to the organizers for inviting me over. I do a couple of more stops, do hackathons, write blogs, and a bunch of other stuff. So if you want to collaborate, open to that. So enough about me. Let's get talking about DSPy. It's an open source framework. Otherwise, I wouldn't have been talking about it. It's a formation of a declarative programming that we call. So my aim here today is to make you fall in love with prompting. The AI generated image that we see here is to make you fall in love with prompting without being frustrated by it. So we'll gonna talk about first class principles into DSPy, how you can program things instead of prompting out, and you'll be using signatures, modules, types of modules, and then of course the charmer in DSPy, I call it optimizers, where you can train your models how we used to do the pre-Gen AI era. Yeah, so let's get started. So let's address the problem in hand. I'm sure you must have seen this, or maybe have used it in your day-to-day any AI system that you're building. We write long prompts, and that's a manual heavy task that we do. And every iteration we try to put in more and more instructions. We try to do some role play. We assign it some purpose. We tell it what to do, what not to do, with a kind of negative prompting as well. And the most tricky part that I get stuck into is that second last thing, output format. So we all want that JSON output of the system, and no matter how hard I try, somewhere in the production it breaks. There's one edge case that will break it, and I thought I had to make peace this way. There's no way out here. But thanks to DSPy, I finally have an answer. So basically, to summarize, prompts are a great way to interact with LLMs, but they do have problem. They are a heavy task to manually maintain the whole thing, and they are unreliable systems. So we can't make them have to be always reliable. So that's something is a real big challenge that we face, and all of this manual effort is quite time consuming. And we don't have a definitive way to know what works and what doesn't work. So yeah, I think that's just a way of saying that LLMs are stochastic parrots. We just tell it what to do, and it does it. But we are developers and we are programmers. We shouldn't go by that OpenAI guide where GPT-4 is supposed to be prompted this way, GPT-5 is supposed to be prompted that way. That can't be the way out, right? You can't be changing your prompts from model to model. That can't be the answer to it. There has to be an efficient way. And DSPy is what helps us with that. So I've been talking a lot about promoting DSPy, and you might be wondering what it is. So it's something that I call it vibe prompting via programming, because instead of you writing in long prompts, you just tell what to do, and DSPy takes care of that automated prompt generation. And it's very Python native. It has support for type hints. It has pydantic support, so you can readily get that JSON output without having to bother about how to write it. And optimizers, of course, how you can fine-tune your prompts, how you can, especially if you're building retrieval augmented systems, that's where optimizers come in to help into fine-tuning your prompts, giving you better instructions, and giving you the best sort of examples that you can feed into your few-shot prompting. All right, so I think you must be excited to already on how to see DSPy in action. So let's get started with it. So this is the very first thing that you do in DSPy. You just pip install it, and then you just get to your, you just define the language model you want to use it. So I tried it out with Ollama. Ollama is a software that allows you to run models in your local system. Especially my system, of course, is not that good to run huge models. So I tried it out with a 1 billion parameter model, which takes around 2 GB of memory and might need you some amount of RAM to run it. Maybe 8 GB RAM is totally fine to run it. So I just plug up that, and it's just this 2 lines of code. And in the backend, DSPy.lm uses light LLM. So you don't need to bother when instead of Ollama, if you want to use OpenAI or Claude or any other LLM model, you just tell the provider name and the model name, and boom, it just works. So I asked it a very good question, that what is US Scala known for, and it gave me an answer. You guys would have to validate if that is correct. But yeah, if you're wondering what the prompt actually looks like, so just do lm.history of -1 and then print the prompt. It is going to show you what exactly the prompt looks like, and this is all the model, this is all DSPy came up with. I did not have to tell it that my question is in this format and answer is supposed to come in this format. I didn't have to tell that. This was all done by DSPy. So that's the magic of DSPy, and we'll see more better things out of it. And this, of course, is a funny meme, but then this blog, I always say to people to go and check out this blog by Hamil Hussain, who's a great person, writing a lot of things into evaluations, which is very important, because if you know about the state of AI now, it's very unreliable. We build a lot of POCs, but there is very less things shipping into production, and it's because of lack of evaluations that needs to be done. So yeah, you must be thinking that, you know what, Jayita, you think we are stupid. You just tell us that what is US Scala known for. ChatGPT can do that, or we can Google it out. What's in store for DSPy? So that's where you can write more efficient signatures. And I think there's a speaker before who spoke about typing. So you can readily use typing here. You just you define a class. So here I went ahead with a very basic thing called sentiment classification, and I gave it an input field, which will be my sentence. And then I want the output to be either positive, negative, and neutral, or neutral. And then the output is of the confidence score that I want out of it, which again, you can define the return type as well. So float is what I defined here. And I just go ahead and say that classify equals to DSPy.predict and just pass in that class. So the output that you see below is something that is already in the format that you can readily extract the sentiment and the confidence. You do not need to worry about the JSON or anything else. You don't need to worry about the prompt that goes in or the training that you need to do it. It readily gives you out the output. Also, the docstring that you see under the function, that also is taken care by DSPy, and that's the very very good thing about DSPy, that if you are able to write in proper doc strings onto the intent that you're or the problem that you're intending to solve, then it will take in that as well. So there are a couple of more modules. Predict is one that we saw, and there is chain of thought prompting. So in chain of thought, what happens is there are certain problems like math problems, puzzle problems. We would need now of course there are reasoning models, but earlier we used to have this long prompt where we used to give in some few short examples on how to solve math problems by giving it that this is how you're supposed to think step by step and solve it. So here, if you use the chain of thought module, you can readily just write a signature, question, and a single arrow to the answer, and just pass in your question, and it will give you the output. So the aim here is to show you the prompt that got generated is something that is happening in runtime, and I didn't write any of this. This was DSPy taking care of it through chain of thought. So it says that this is my question, and reasoning is think step by step in order to produce the answer, and then again the answer comes in. So it's that easy. Another good thing is if you are intending to build agents, so React is something that you can use, which stands for reasoning and action. So React module can be very helpful to that. So if you see, I've defined two tools here. One is the math, and other is the Wikipedia search. So either whatever questions that I give, it either the LLM understands the intent and routes to one of these two tools. So that was a math problem that I gave it, and it understood and went forward to the evaluate math function. And the very good thing here, if you see, is my arrow visible? Yeah. So here, again, I can define the return type as well. So that's a very good thing to ensure how my output is going to be. So I just gave in this math question, and it understood it had to give me out. It has to route to the evaluate math function. If you see here, it is using a Python interpreter to execute. It's not going into an LLM to generate, suppose say if we take the very basic example of a calculator to do addition, subtraction, multiplication, division, and it will not go 2 plus 2 to go to the LLM to output 4. It will rather execute it through Python itself by calling this Python interpreter function. And so if you see here, we can readily extract the answer with predict.answer, and this was the answer that it gave. Now, if you're wondering how did DSPy come up with the prompting for this React agent, so it has 4 parameters onto it. It has the question, the trajectory, the reasoning, and the answer. So question, of course, is very, very self-explanatory, that whatever user input that comes in. Trajectory is how the tool is getting executed, how the thought process of the tool is happening, what are the steps that it is executing, and how is it reasoning it out. So reasoning comes under that. And then finally, the answer that the tool would arrive to. And yeah, all of this, I did not write it, DSPy took care of it. So we come to the very, very great thing about DSPy is optimizers. So I work into RAG systems, retrieval augmented generations. In one word, it is like extracting information out of your private data, which you cannot directly give it to an LLM. So you would rather do information extraction fast out of it, and then out of the top matches, the generation process happens. So in RAG systems, earlier what we used to do is that we just plug up the data source, and then the RAG pipeline works, and we do a bunch of prompting on how it is supposed to get the answer. But we did lack on evaluation and making the prompts better. It was really nerve-wracking on how I said the very first slide that we saw, that every time it did not generate a good answer, we would tweak the prompts. Of course, in RAG, there are other parameters to consider as well, but let's just focus on the prompt part here. And DSPy offers us the good thing about evaluation, which is like, say you're building a customer care chatbot where you know what the golden answer should be. You have a golden or a ground truth answer set, which is written by an SME or somebody who has manually over the years been answering from that, and you have your bot answering it. Now, to evaluate, you would obviously compare how close your chatbot answer is to the ground truth answer. So that's where optimizers can help you. There are kinds of optimizers. The one is few shot learners, which will try to get out of the training the best sort of examples from there. Label few shot, bootstrap few shot. We're going to see one today, bootstrap few shot random search. And there are automatic instruction tuning also. So if you don't want to just generate examples, best few shot examples, you can also tweak the instruction set that you have given. And of course, you can do the automated fine tuning as well. So anybody here from the pre-Gen AI era, the machine learning era, would know that how we used to fine tune the models. We used to tweak the top layers and the weights of the model to get the answer out of it. So if you're wondering which one to apply for your use case, it's obviously an experimental and iterative process, but I took this from the DSPy official documentation. There are some ground rules that you can do. Is if you have very less examples, say around 10 or so, you can go with bootstrap few shot. If you have 50 or more, you can go with bootstrap few shot with random search. And if you want only to the instruction set to be modified, not generate few short examples, then go with MePro v2, and so on and so forth is there. And in the end, we'll also see GEPA, which is like a charmer. It has RL in the training, which you can use and do the training for your model. All right. So this is a basic code for bootstrap few shot with random search. So I took the GSM 8K data, which is a math and reasoning data set, how you're given a math problem and how do you solve it. So it's a famous data set. You can get it from Hugging Face. So you'll see there. So the aim here is to train a model which can generate more best few shot examples that can be given to the prompt, and we'll see what the initial prompt and the final prompt version looks like. So to implement this, it's very simple. You just go ahead. If you want, you can import this dataset directly from DSPy.datasets, or if you want to use any other dataset, you just import that one, and you just define your LLM to be used. I'm using Gwen 332 billion from Grok. And then you just define which module you want to use. I went ahead with COT. If you think React works better, you can try that out. And then just define the bootstrap few shot random search parameters. So here, if you see, it is taking max bootstraps demos of 8 and so on and so forth. You can. So these parameters are of course not the ideal hyperparameters. You have to iterate over and see what works best for you. And then you just call the teleprompter.compile and pass the module and your training data set onto it. So this just, I would say it's 10 lines of code or so, can make a huge difference. Although, training the model will take you some time based on the compute power and the dataset size that you have. Okay, so I should mention about MLflow. So it becomes difficult to track your training processes. So MLflow is an observatory tool, which again is open source. You can just pip install it, and I hosted it up on my server as well. So by default, if you don't mention the port, it will take 5,000, and you can see what your training runs look like, the traces, how exactly the training process is happening, what are the calls that the model is making while training it. So it really becomes helpful rather than just looking at the logs and trying to make sense out of it. So this is the initial prompt that we had in the left-hand side. So if you see, it was a very basic prompt where it only had certain the input fields, the output fields, and no such examples. So after we trained the model, The right-hand side is what you will see starts from, I think, line 25, user message. So that's where the model identified the best sort of examples, few short examples, and feeded it. And that, when given to your system, it would understand how better to give an answer. So you basically teach the system how to answer a reasoning question. So yeah, that was for few short examples. Now, if you want to tweak the initial instructions that you give to the model, that's when you can use MePro v2. So MePro v2 is very powerful. It can do both things for you. It can generate few short examples as well as instruction tune it. If you don't want it to generate few short examples, you can just turn off the parameter for that. Again, it's a very simple code that you can see, similar to what we saw for Bootstrap. You just define certain parameters. Again, this is also on GSM 8K data. You just define the parameters, and then you run the optimizer program for it. And again, you can trace it with using MLflow so that you know what are the calls being made, and you can see how the improvement over time happens. So if you wish to then see the evaluation results of the unoptimized model versus the optimized model, then you can just run the evaluate, DSPy.evaluate. So this is taking the very basic metric, which is accuracy or F1 score. If you want, since this is open source, you can go ahead and define your own metrics that will be working for your use case, so you can define that. And then this of course took me a long time, because I think I was running in my local system, and it was a small model which was over time working. So I think it took me around 8 hours to get over 10 rounds of evaluation. But the results I'll show you were really useful here. So if you see, these were my training runs that I did, and this is how it went from 67 to an average of 82. So this was how it kept evolving. And after the evaluation is done, you get a data frame which looks like this. So how was your golden set answer and golden set reasoning versus how is it now the model answering you? And if you see towards the very end here, you will see that the unoptimized model was 64 and the optimized model is now giving you a score of 82. So that's close to a jump of 20%, 18% to be exact. But yeah, that's really a massive win, I would say. So MLflow, I really love MLflow, because you can the other best thing about MLflow is you can compare your evaluation runs. So if you want to compare eval 1 versus eval 10 to see how the model has evolved over the generation process, so you will see that the first one here was giving you very basic reasoning, and maybe it's not that detailed out, but the second one has detailed out things, and it's a big one. It's arguable whether model is overthinking or not, but yeah, it does seem to do a better job at the second one. So yeah, we've been talking about so many optimizers and how they work in generating few short examples, and they work best at giving you instruction sets as well. GEPA is comparatively a new optimizer that DSPy has integrated. The best thing about it is it uses reinforcement learning to learn the best examples and also penalize the model onto what are the bad examples. So that's really powerful, and even you can give feedback on the runs as well, so that the model on the go runs and tries to execute it. So the very basic thing that you can do here is in any RL system that we do is we have a teacher model, which is a very powerful model, a bigger model, and we have a small model which we will try to optimize using that larger model. So that teacher and student model you can define and try to optimize your prompts or the instruction sets. So that's how it does. Maybe you can, I don't think there's much time, you can go over the paper that was released, and they have explained it beautifully on how they generate the candidates at every iteration. and through that they are able to really see a massive good performance. So they ran it on Amy, which is like again a math data set, and they were able to see GPT 4.1's performance improve by 10%, and that's really a great one. If you see the final prompt that came out, it really has got into very nitty-gritties of the use case, so domain-specific strategies and pitfalls. So that's very niche that a model can bring out from a data set, that what exactly are the things that it should focus on and what exactly it shouldn't. So that's a really good one. Yeah, I guess that's more or less from my end. If you want to get access to the slides, then you can just scan it. And yeah, these were some of the references that I was using. Obviously, the official DSPy docs, MLflow docs, and there's a new course by Deep Learning, which they recently came out with, DSPy Build Optimize Agent Apps. There's a beautiful newsletter by my friend Ankur. He writes really well on whatever latest that is happening on DSPy. He has it on his newsletter. Couple of YouTube videos you can go through to understand better. And of course, if you want to join the Twitter channel and the Discord channel, the founders of the DSPy, Omar Khattab, is very active in that. Whenever you face any problem, just post it there and there's a solution for you. Yeah, thank you so much for your time, and I'm open to questions.
Okay, do we have a questions somewhere here? There's one.
Okay, I have one question. So let's say I have a fine-tuned version of Gemini model in the Vertex AI in the Google Model Garden. But only way I can interface with this model using the service AI service account authentication. So does DSPy support that service AI authentication?
It's open source, so I think it's under MIT license. You can check that up. I'm not really recalling the exact license, but it's open source. You can directly...
No, it's not about the license. Like the authentication mechanism, which we saw in the first slide, it was like API key. But in Gemini Model Garden, you cannot directly connect to the model using the API key. You have to use called Google Service Account JSON file.
Yeah.
So does DSPy support that?
Yes. They have Gemini support, so you can check that up.
Gemini basic model and the fine-tuned model has different authentication mechanisms.
But you can connect to the service account. I've used Gemini and Vertex AI, so yeah, you can do that.
Yeah, thanks for the presentation. So one question is that can we use different models for prompting and prediction here? And if so, then how would you decide like which model to use for prompting and which for prediction?
So you can do that in GEPA. Then you can do that if you want to like have a teacher and student model relationship there. There you can do that. The one that you want to optimize it on top of, then you can do that. But I mean, for inferencing generally, we would have configure it to one single LLM only.
Yeah, why I ask it is because some models can be very expensive, and then if there's a lot of predictions, so typically you think a lot and design a prompt, and then you do like a lot of predictions there. And if we are using like a cheap model, then this prompt might not be good quality, and then it would not go well in the predictions as well. So how do you solve such sort of a problem here?
I mean, I understand your concern that optimizing this, every call that it makes will be a costly thing to do. But yeah, I think I don't have a definitive answer to that. Maybe, with experimentation, we can find out.
Sure. Yeah. Thank you very much.
Thank you. So does DSPy provide any benefit over structured output if you're trying to get fairly sophisticated JSON schemas back out of the system?
Yeah.
this is one of the struggles that the system has.
Yeah.
And what was interesting about the output that DSPy was producing, it looked very similar to kind of what the boundary ML guys are using in their sort of schema, sort of a markdown schema thing. So could you tell us a little bit about that? How do you guys...
Yeah. If you see here, the React module that I was explaining you, instead of you just directly do predict.answer and it gives you the answer. You don't need to bother about telling it that I need a JSON answer and so on and so forth. You just put in your question and the shorthand notation here, the return type, and the tools that you want to use if you're using React, and then you just do predict.answer. That's it. You don't do that old native way of OpenAI choices of 0 of messages, not at all.
Right. So I guess, so if we have a fairly complex structured output that's coming out that's not like something simple, is it, because it looks like it's breaking things down with these brackets, and so it kind of is holding its own sort of representation of the answer. So you're going through DSPy that is doing that parsing. There is no sort of, so that's it. There is no structured output in the sense of JSON schema and so you just don't do that.
Okay. I mean, you don't prompt it to do in JSON. It takes care through Pydantic. It validates that and gives you that answer. And if you wish to like tweak the prompt that it is natively using, you can do that. It's open source, so you can go to the actual backend script and change there. So I think we did that in production in my company, that we actually went to the module. So many a times it is adding new lines, and I don't want that for my case, so I can tweak it there.
All right, thank you.
Let's try there.
Hi, thank you for the talk. Have you tried running the DSPy for like complex agentic kind of chains, kind of evaluating or optimizing the tool call outputs instead of the kind of regular response for like some complex agentic situation?
Not really. My implementation is restricted to RAG systems, so not an agentic one, but I'm sure they can do that. I think when you're optimizing here, I think I showed the example using COT. If you want, you can change it to React, define tools on what to go and where to execute, so that's totally possible.
Yeah, I find it a little bit annoying to evaluate and optimize, because like regular, like just, RAG systems where you get a response, that's like kind of easier, much easier than you have a complex, like some kind of agentic workflow, and then evaluating that and optimizing that is like, seems a little bit of a nightmare, but yeah.
Okay, I would like to learn from you, your learnings then.
Thanks. Any more questions?
I'm sorry, I'm not really into this LLM stuff, so maybe my question will sound stupid sometimes. You not you personally, maybe like when working with DSPy, you're dealing with training data sets from time to time. Are these data sets supplied with the library, or does it download it when requested? Like, how does it work under the hood?
So this one, you can directly use it from, like, this is a thing that they already have in their system, so it will again download it to your own system. But other than that, also, if you want to like use any data set from your maybe local system, it's a JSON file or anything that basically has this kind of data, you can transform it into a data frame, having the question, the answer, the reasoning, if you're using that, and then just use it up.
I'm mostly concerned with ones that are supplied, that in some situations you do not want to suddenly trigger some huge download. And if it won't happen automatically, then okay.
You can restrict that. Like suppose I want to just train on first 50 rows. So you can tweak that if once you take it into a data frame.
Okay.
Well, thank you. Let's give her applause.